Hello students, welcome back to my channel once again. So today we will be covering the CBSE board grade 9 mathematics chapter Heron's formula. So in the previous video I explained Heron's formula, that is the part 1. So if you have not yet watched that video, please go and watch that first, otherwise you will not be able to understand this part 2. Okay, in the part 1 we have discussed what is Heron's formula and then we solved some problems. So now today we will also look into this Heron's formula and we will solve some other problems together. So the first question is, an isosceles triangle has perimeter 30 centimeter and each of the equal sides is 12 centimeter. Find the area of the triangle. Okay, so what is given? That a isosceles triangle is given. Isosceles triangle means where two sides are equal, and we need to find, and another information is given, that is the perimeter. Now we need to find the area of the triangle. So what is the formula for the area of the triangle? So the Heron's formula is square root of s into s minus a into s minus b into s minus c. And s is over here the semi-perimeter, that is the half of the perimeter. Now here a and b, that is the equal side, that is given, that is 12 centimeter. Now we need to find the other side c. So perimeter we know that is 30 centimeter, and perimeter means sum of all sides, that is a plus b plus c, that is equal to 30 centimeter. So now here we know a and b value, so just put the value over here, then we will get the c value. So c will be equal to 30 minus 24, okay, because 12 plus 12 is 24. So that is coming 6 centimeter. Okay, so now we got the three values, three sides of the triangle. Now in order to find the area of the triangle, we should know the value of s. So as I already told, that s is the semi-perimeter, means half of the perimeter. So now half of the perimeter will be 1 by 2 into a plus b plus c, that is 30. So which is coming 15 centimeter. So s minus a will be equal to 15 minus a, that is 15 minus 12, which is coming 3 centimeter. Similarly, s minus b is also 3 centimeter because a and b are same. Now s minus c will be 15 minus 6, which is 9 centimeter. So now we know all these values. Now we have to find the area. So area of the triangle will be equal to square root of s into s minus a into s minus b into s minus c. Now put all these values over here. So s is 15. Now put s minus a value, then s minus b value, and finally s minus c value. So 15 into 3 into 3, and 9 will be 3 into 3. Now we can see there that there is one pair of 3 and there is another pair of 3. So these 3 will come out, these 2, 3 will come out, and 15 will remain inside the square root. So that is 9 root 15. Now we need to do the decimal long division to find the square root of root 15. So to find the square root correct, we need to do the only correct up to one decimal only. Okay. So after decimal, we will take only one decimal point. So we have to take only one pair of zeros after the number here, since we are taking only one decimal point. So which is the number whose square is less than or equal to 15? So I hope you remember that long division process. So first we need to take a number whose square is less than or equal to 15. So that is 3 square, that is 9. So we will write 3 over here, and at the top also we will write 3. So that becomes 9. 3 into 3 is 9. Now if we subtract, we got 6. Now we will just take down this pair of zeros. Now 3 into 2, or you can take it as 3 plus 3. Just you have to add those three values, like whatever is given in 3, and we have to take that upper 3 and we need to add that. So we got 6. Now, which number should be written beside 6 such that when we multiply the new number formed with the same digit, we should get a number equal to or less than 600. So we have to think of a digit which we can place just beside 6, because we have to multiply whatever digit we are thinking, we have to multiply with that digit only, so that the number we will get, that should be less than or equal to 600. So it will be, if we put 6 and after 6 if we put 8, which becomes 68. So 68 multiplied by 8, because we have to multiply with the same digit, that is 8, which is coming 544. So if you multiply 69 into 9, it will come more than 621. You can also check that. So that's why we will not take 9. So we have to take 8 over here. Okay, so we know that 544 is less than 600. So we will take 8 over here. And we will write that 8 after the decimal point, because we have bring down that zeros. So decimal point we have to write. Now 544, 56 will be the remainder. Now we can ignore that 56, because we have to take only one digit after the decimal point. So 9 into 3.8, which is coming around 34.2, and the unit will be centimeter square. Okay, so don't forget to write the unit. Now coming to the next question. A park in the shape of a quadrilateral ABCD has angle C equal to 90 degree, AB equal to 9 meter, BC equal to 12 meter, CD equal to 5 meter, and AD equal to 8 meter. How much area does it occupy? So here a quadrilateral figure is given, and they have specified some length, sides, and one angle is given. Now we need to find the total area. So angle C is 90 degree, that is given. AB is 9 meter, BC is 12 meter, CD is 5 meter, and finally AD is 8 meter given. We need to find the area. So quadrilateral ABCD is made up of how many triangles? So first we need to check that how it is means how many triangles are there within this quadrilateral. So there are two triangles. So if we can find out the area of these two triangles and then add up, we will get the area of the entire quadrilateral. So that the triangles are triangle BCD, and another triangle is triangle ABD. Now so what we found, that area of quadrilateral ABCD is equal to area of triangle BCD plus area of triangle ABD. Now first we need to find out the area of triangle BCD. So triangle BCD is what type of triangle? Can you recognize the triangle? So one angle is 90 degree. So that means it is a right angle triangle. So now what is the formula for the area of triangle BCD? So since this is a right angle triangle, so we don't need to consider the three sides. We can use the formula, that is half into base into height. Okay, then it will be easier. We don't need to know the third side. So that is half into BC into CD. So which is coming, the area of triangle BCD is equal to half into BC into CD. That is equal to half into BC is 12 and CD is 5 meter. So which is coming 30 meter square. Now we need to find the area of the triangle ABD. So now in this case, we have to apply the Heron's formula, that is square root of s into s minus a into s minus b into s minus c. Right? Okay. Now for triangle ABD, AB is given, that is 9 meter. AD is given, that is 8 meter. Now BD we don't know. BD is the C we can consider, that we don't know. Okay. So we have to find BD first. But if you check, BD also belongs to the right angle triangle BCD. And what is BD over here? BD is the hypotenuse of triangle BCD, right? So now we can apply the Pythagoras theorem. So Pythagoras theorem, we have BD square equal to BC square plus CD square. So now BD square will be BC square means 12 square plus CD square means 5 square. So that is 144 plus 25, which becomes 169. So BD will be square root of 169, that is equal to 13 meter. So now we got all the three values of triangle, all the three sides of triangle ABD. Now let us calculate the area of triangle ABD. So A is 13, B is 8 and C is 9 meter. So now in order to find the area of the triangle, we should now know the value of S. So what is the S? S is the semi-perimeter, that is half of the perimeter. So let's calculate that A's value first. Half of A plus B plus C, that is half multiplied by 13 plus 8 plus 9. So which is coming half into 30, that means 15 meter. So now we need to find S minus A, that is equal to 15 minus 13, that is 2 meter. S minus B is 15 minus 8, that is equal to 7 meter. And finally S minus C is 15 minus 9. So which is coming 6 meter. Now we have to apply the Heron's formula to find the area of triangle ABD. So now put the values of S and S minus A and S minus B and S minus C as well. So what we got? Now let us factorize 15. So 3 into 5 into 2 into 7 into 2 into 3. So now take a group. So we can take 2 as a group, 3 as a group, okay, 5 and then 7. So 5 and 7 cannot be grouped. So 2 and 3 will come out and 5 and 7 will remain inside the square root. So it will become 35. So now we need to find the value of square root of 35. So let us do the division. So here let us find the square root correct up to 1 decimal only. So we have to take only one pair of zeros after the number, since we are trying to find only one decimal number. So 35.00. So which is the number whose square is less than or equal to 35? That is 5, because we know that 5 square is 25, 6 square is 36, which is greater than. So we have to take 5 here. So we'll write 5, and at the top also we'll write 5. So 5 into 5 is 25. That will be the remainder 10. Now 5 plus 5, that will become 10, and we have to bring down that 0. Now which number should be written beside 10 such that when we multiply the new number formed with the same digit, we should get a number equal to or less than 1000. Okay. So now if you multiply 9, if you take 9 over here, so that number becomes 109. So we have to multiply with 9 only, the same digit. So 109 into 9 is 981, which is less than 1000. So now we have to also put 9 after decimal point. So the remainder is 19. Now remainder we can neglect that part because we got one decimal point. So 6 into 5.9. So if you calculate, it will come around 35.4 meters square. That is the approximate value. Now this is not the end. Now we have to find the value of area of the quadrilateral. So we have to add the area of the triangle BCD and the area of the triangle ABD. So area of triangle BCD we already know, that is 30 meter square, and area of triangle ABD is 35.4 meter square. So if you add up, which is coming 65.4 meter square. So this is the area of the quadrilateral ABCD. Okay, now coming to the next question. The question is, Find the area of a quadrilateral ABCD in which AB equal to 3 cm, BC equal to 4 cm, CD equal to 4 cm, DA equal to 5 cm, and AC equal to 5 cm. Okay, so the quadrilateral is ABCD given, and they have given the sides. AB has 3, BC has 4, CD has 4, DA has 5, and AC has 5. Okay. So now we have to find the area of the quadrilateral ABCD. So area of the quadrilateral ABCD, this is a similar type of problem that we did earlier. So that will is equal to sum of area of triangle ABC plus area of triangle ACD. Okay, now we need to find the area of triangle ABC. So area of triangle ABC, here if we can check AC square equal to 5 square, right? Now let us check AC square, that is 5 square, means that is equal to 25, correct? Now let us check AB square plus BC square. So AB square plus BC square, AB is 3, so 3 square plus BC is 4, 4 square. So that is equal to 9 plus 16, which is equal to 25. So what we got, if we compare this equation 1 and equation 2, so what we got, that AC square is equal to AB square plus BC square, right? So what we conclude from here, that this is a Pythagoras theorem, right? So that means angle ABC should be 90 degree by using the converse Pythagoras theorem, right? So now we know this is a right angle triangle. So to find the area of the right angle triangle, we can apply the formula as half into base into height. So here the half into base into height will be equal to half into base is 3 cm, and that is AB, and height is BC, that is 4 cm. So now put the values. So finally we got 6 centimeter square. So that is the area of triangle ABC. Now we need to find the area of triangle ADC. Now here let A is AD, that is equal to 5 centimeter, B is DC, that is 4 centimeter, and C is AC, that is 5 centimeter. So now we have to apply the Heron's formula. So we know that to find the Heron's formula, we have to first find the value of S. So that is half of perimeter. So half of A plus B plus C. So half of 5 plus 4 plus C is 5. So that is equal to half into 14, that is 7. So AC is 7 centimeter. Now apply the Heron's formula, that is square root of S into S minus A into S minus B into S minus C. So now S is 7, S minus A is 7 minus 5, S minus B is 7 minus 4, and S minus C is 7 minus 5. So square root of 7 into 2 into 3 into 2. So here we can make a pair of 2. But 3 and 7 will remain inside the square root. So that means square root of 21. So area of triangle ADC is 2 square root of 21 centimeter square. Now we need to add those together. So area of triangle, to find the area of quadrilateral ABCD, we have to add area of triangle ABC and area of triangle ADC. So that is equal to 6 plus 2 root 21. So now if you take common, then it will become 2, 3 plus square root of 21 centimeter square. If you want, you can also do the division method of square root to find the square root of 21. That is also correct, or you can keep as it is. Both way is correct. So this is the final answer. Now coming to the next problem. Radha made a picture of an aeroplane with colored paper as shown in figure. Find the total area of the paper used. Okay. So now we have to find the total area of the paper used. Means in order to find the total area of the paper used for the aeroplane, we have to add the area of each part of the aeroplane. Okay. So there are multiple parts. This figure has, now we have to identify this figure as how many parts. Okay. So in part 1, there is part 2, part 3, part 4 and part 5. So 5 parts are there, right? Now, how many are triangles? There are 3 triangles. That is 1, 4 and 5 are triangle. And part 2 is rectangle. And part 3 is a trapezium, right? So now, area of the paper used will be equal to area of part 1 plus area of part 2 plus area of part 3 plus area of part 4 plus area of part 5. Now area of part 1. So what is the formula for area of triangle? Because part 1 is the triangle. So that is square root of s into s minus a into s minus b into s minus c. Now here a is 5 centimeter, b is also 5 centimeter because it is a isosceles triangle. As means just by checking we can clearly say that both the parts, both the sides are equal, and c is 1 centimeter, right? So now s is equal to half into a plus b plus c. So that is equal to, now put the values over here. So 11 by 2, that is 5.5 centimeter. Now find the area of the triangular part 1 using the Heron's formula. So that is square root of s into s minus a into s minus b into s minus c. Now put all these values together. So that is 5.5 into 5.5 minus 5, 5.5 minus 5 again, then 5.5 minus 1. Now which is coming 5.5 into 0.5 into 0.5 into 4.5. Now 5.5 means 55 by 10, 0.5 means 5 by 10 and 4.5 means 45 by 10. Now 55 we can write as 5 into 11. Then 5 we will keep as it is. The next 5 we also. And 45 we can write as 5 into 9. So we can make, and in the denominator we can make a pair of 100. So there we got one pair of 5. Then we got another pair of 5. Then we have 9. So 9 can be written as 3 into 3. So 2 pair of 5 we got. So 1 5 and 2 5. Second 5 will also come out. So that means 2 5 will come out and also the 3. But 11 there is no pair. So 11 will remain inside the square root. Divided by. So there are there is a pair of 100. So 100 will come out from the square root. So which is coming 5 into 5 is 25 into 3, 75 by 100 square root of 11. So 75 by 100 is 0.75 square root of 11. Now if we do the decimal division of 11, decimal square root of 11. So we have to find only one. We have to find the square root correct up to one decimal only, right? So we have to take only one pair of zeros after the number. So 11.00. Now which is a number whose square is less than or equal to 11? That will be 3 because 3 square is 9. So now 11 minus 9, that is 2. Now we will bring down this 0 and we will put a decimal point after 3. Now 3 plus 3 will be 6. Now we have to put a number, or we have to put a digit just beside 6 such that when we multiply, the new number formed will be with the same digit. We should get a number equal to or less than 200. So that should be 63. So we have basically we are putting 3 over here. So 63 into 3 is 189, which is less than 200. If you put 4, then it will be greater than 200. So that's why we have to put 3 over here. And also we need to put this 3 after the decimal point of 3 at the top. So now multiply this 3.3, we got approximate value as 2.475 centimeter square. That is the area of the part 1. Now we need to find the area of part 2. So part 2 is basically a rectangular area. So rectangular area formula means length into breadth. So here length is 6.5 and breadth is 1. So the rectangular area will be 6.5 centimeter square. Now we need to find the area of part 3, that is the trapezium. So what is the formula for trapezium? Formula for the area to find the formula for finding the area of the trapezium is half into height into sum of the parallel sides. So now in this case, half into sum of the parallel sides. So if you take a look, the parallel sides are 1 centimeter and 2 centimeter, right? So if we name it as ABCD, so just we have I try to zoom this figure and try to explain that. So AB is 1, AD is also 1, BC is 1, and the lower part, that is CD, is 2 centimeter. So AB and DC are parallel, right? So now let us draw height for the trapezium AE, and that will be perpendicular to DC, and BF, that is perpendicular to also DC. Okay. So now half into AB plus DC, that is the sum of the parallel sides, and height we can take any value like AE or BF. Now we know lengths of AB and DC. AB we know, and we only know and also we know DC, right? So AE belongs to which triangle? So if you take a look, AE belongs to the right angle triangle AED, right? Now in right angle triangle AED, how can we get the length of AE? So let us take a look by using the Pythagoras theorem. So we know that in triangle ADE, AD is the hypotenuse. So AD square will be equal to AE square plus DE square. So since AE is perpendicular to DC, so right angle triangle AED is in AED, AE square plus D square is equal to AD square, right? Now DE, that we don't know, right? So DE, we can say that D is basically DC minus EF minus FC, right? So, or either we can say DE is equal to DC minus EC. So now what is EF? EF is same as AB, right? Because EF is the side of the rectangle ABFE, isn't it? Okay, so now AB and EF are opposite sides of the rectangle ABFE. So AB and EF will be equal to same, because opposite sides are equal, that is equal to 1 centimeter. Now what is FC? Now we have to check FC belongs to which triangle. So it belongs to BFC, right? So now can we prove that angle AED and angle, my mistake. Can we prove that triangle AED and triangle BFC congruent? So if we can prove those are congruent, then D is equal to FC, right? So let us try this. So in triangle AED and triangle BFC, angle AED equal to BFC because both are 90 degree. AD equal to BC because both are same, right? and AE is equal to BF because both are height, so always it will be equal. Now, so by using RHS rule, we can say that triangle AED is congruent to triangle BFC. So it should be a congruent symbol, not equal symbol. So by CPCT, we can say that DE is equal to FC. Now CD. Now look at here. CD is equal to DE. Now what is CD? CD is basically equal to DE plus EF plus FC. Right. So now CD we know that is 2 centimeter. DE is equal, and DE we need to find out. EF we know 1 centimeter. And FC, instead of FC we can write D, right? Because we already conclude that earlier that DE and FC are equal. So now which is coming, that 2DE is plus 1 equal to 2. So 2DE is equal to 1. So DE will be 1 by 2, that is 0.5 centimeter. So we found the value of DE. Now AE square, our main target was to find AE, right? So AE will be equal to AD square minus D square. So AD is 1 square, AD is 1 and DE is 0.5 that we just now got. So 1 square minus 0.5 square, that is 1 minus 0.25, which is 0.75. So AE square is 0.75. So 75 we can write it as 75 by 100, which becomes 3 by 4. So AE will be equal to square root of 3 by 4 centimeter. I know this problem is going a bit lengthy. Now area of trapezium will be equal to half into AB plus DC. So AB is 1 and DC is 2 into AE. AE just now we got root 3 by 4. Okay, so that is half into 3 into root 3 by, so 4 will come out, so it becomes 2, right? So what we got, 3 root 3 by 4 centimeter square. So root 3, we take the approximate value as 1.732. So final answer we got is 1.299 centimeter square. Now, if we take a look at triangle 4 and 5, both triangles have equal side length, right? That is, now, so their areas will be also equal. So if we can find the value of one triangle, then the other value will be equal to that one. So now, here both are the right angle triangles. So now what is the formula for area of these right angle triangles? That is half into base into height. Now area of part 4 plus part 5 will be equal to 2 into half into base into height, because both are same. So that's why we are doubling it, right? So half into base over here is, so if you take a look, the base is 1.5 and height is 6 centimeter. So if we divide, we got 2 into 3 into 1.5, that is 4.5. So that is equal to 9 centimeter square. Now we got all the 5 parts, right? Now the area of paper we used will be equal to, we have to add all of this together. So area of part 1 is 2.475, part 2 is 6.5, part 3 is 1.299, part 4 is 9 and part 5 is also 9. Right? So if you add, sorry, my mistake, part 4 and 5 we earlier we got it together. So the part 4 and part 5 together is 9. Okay. So if you add up, so we got the total area used is 19.274 centimeter square. I know this problem is a bit lengthy. I hope it is clear to you, right? I'm just showing you once again. So part 4 and 5 together. Okay. So this is the full area. So if you are not clear, you can just go back and recheck once again, because this problem is a bit lengthy. So if you are not clear about it, just go back and please rewatch it once again. Okay, then I think it will be clear to you. So this is the end of today's session. So I hope you have understood all of the problems. If you have any doubt, you can put those doubt in the comment section. And if you like my video, if you understood the problems, please just hit the like button, and please do share with your friends so that they can also go through the problems and they can understand the problems, right? Okay, so that's all for today. I'll be coming up with another video of Heron's formula where I'll be covering more problems on Heron's formula. Okay, so please, for that, you need to subscribe to my channel. Otherwise, you will not get the notification of the new videos that are coming up. Okay, so just press the bell icon and you will get notification whenever I will upload any new videos on Heron's formula. Not only Heron's formula, I will keep on uploading another other videos of different topics for grade 9. So please be tuned on that in my YouTube channel. Okay, that's all for today. Thanks for watching the video. Bye bye.